Good afternoon, everyone, and thank you, Bashid bhai, for the introduction. So, client side to critical is the topic, and let's see what we are going to see ahead. So, first, who am I? I am Satyam Gothi. I go by the name of Rogue SMG. I am a full-time bug bounty hunter. I was an ex-chapter leader at Null Ahmedabad. I also create content on YouTube, and I go by the name of Rogue SMG there. And we also have founded a small thing for the community, and we are developing that at barracks.army. And with me, I have Kuldeep Pandya, and over to him for the introduction part.
Hello everyone, myself Kuldeep Pandya, and me and Satyam both have kind of very similar bios. I am also a full-time bug bounty hunter. I am also an ex-chapter leader at Null Ahmedabad. Most of you may know me from my blog at kuldeep.io, and I am also a co-founder of barracks.army. Over to Satyam.
So this was just small about who am I. Now let's look at the agenda for today. So first, we are going to see why we are doing what we are doing, obviously. Then we'll have a very technical breakdown of how the JavaScript works, how client-side things work. Then we'll see a debate between observation and automation, like why not just automate everything and why even bother doing all this. Next, we'll dive into the psychology that led us to finding critical issues and which enables us to find critical issues without going crazy. And finally, we'll see overcoming some challenges, and that's pretty much it. Next. So, 2 days before, this came on my InShorts feed, and I just wanted to add this here. This is just to give a context to you guys that sticking to the basics, even in this modern era of AI, definitely can land you bounties. If people can still rob using pigeons, we can land bounties without using crazy automation or stuff like that. So this was just for that context. Now, what is JavaScript? JavaScript basically is just a piece of code which helps to make your web applications dynamic. So whatever you see, all the interactions happening on the web page, everything happens through JavaScript. And that is the only piece of code that we are able to see from a black box perspective. Right, and web tech by nature is stupidly designed in such a way that we already have access to that client-side code. And as you can assume, if we have access to some kind of code, and if you have access to information and you know how stuff moves, then it enables us to create a gateway of F-word apps. So, yeah. And before you guys sue me, let me tell you that we are obviously going to see stuff beyond the basics, which are the hard-coded stuff like API tokens, secrets, and passwords, etc. And examples will include. So these are the examples. Of course, we can have the hard-coded secrets in the JavaScript code. We can also have undocumented endpoints, which are basically endpoints which you will not find anywhere in the flow of the application, but they are documented somewhere in some form in the JavaScript. We also have flawed custom functions and critical logic on client side. So this basically means that some kind of critical logic or calculation is happening on the client side itself instead of on the back end. So these are a few examples of what we are going to see ahead. Now let's dive into the technical aspects of JavaScript and client-side stuff. And for that, let me hand over the mic to Kuldeep, and he'll take this forward. Thank you.
So thank you so much, Satyam, for the introduction. Now we'll see all the technical stuff and very small and big, what do we say, tips and tricks about JavaScript. So next. So the technical agenda for today will be unminifying JavaScript, then making sense of JavaScript source maps, then we'll see how to override JavaScript and how to unbundle JavaScript. So first up, we'll see JavaScript unminifying. Now, if you open a web application and before you even try to analyze any JavaScript, you'll likely see spaghetti code that looks like this. It doesn't mean anything to you because we are not robots. We cannot understand minified code, right? For us to analyze something or or to even make any sense of JavaScript, we'll need unminified code. So now I can already hear some of the AI bros in the back saying that just throw this into GPT, just give it to GPT, it will give you unminified code. But let's be honest, that's not practical because context of AIs is limited. If you throw it, JavaScript files are very large. In fact, in production application, JavaScript files are large because they are mostly bundles. And AI has limited context. JavaScript files may be like 8 to 10 megabytes of size, but the context might be like 2048 bytes or something like that. I'm not an AI bro. So one technique that you can use is in the previous file, the file name was barracks.min.js. But if you want to minify the file, you might try simply like barracks.js. You may remove the min keyword from the file, and it might show the unminified file. Like this is purely luck based. It might be your luck if you see the unminified file, but this works in like 3 to 10 files. Next up, we have JavaScript unmapping. What is a webpack? When you create a web application using React, it will create a webpack. The webpack looks something like this. In a webpack, you will see lots and lots of comments and references to webpack. Like in the first line, you can see it says webpack bootstrap. Many of you may have seen files that look like this. And at the very end, you can see there is index.js.map file. So what is this map file? If you open the file, it looks something like this. So here, this is the typical syntax of a map file. You don't need to understand the syntax because we'll just throw this into a tool and the tool will unmap the file for us. Next. So the tool is called unmap. Here you can see we are throwing the app.js.map file into the unmap tool, and the unmap tool will take the file and unmap the actual webpack into individual source files. So here we can see the file is main.typescript file. The file that we initially had was index.js with lots and lots of webpack stuff. But here we say that we have main.typescript. This is the actual file that the developer wrote. Next, we'll see some of the limitations of burp.js link finder tool. Now, many of you, including myself, use this tool, but even this tool has its limitations, and we'll see how. This is the typical output of the burp.js link finder tool. You can see there are some endpoints and URLs. Now here in the screenshot, you can see that there is a request to API v1 leaderboard. But if you search the output of the burp.js link finder, you can see that the leaderboard endpoint is nowhere to be found. So the front-end application knows that the endpoint is present. The backend knows that the endpoint is present, but the burp.js link finder tool doesn't show us. Like it's not the tool's fault because it uses regex, and the front-end applications are constantly changing. So it can't keep up with all the changes. Next. So to overcome the limitations, here are some strings that you can search for in the JavaScript files. The first one is base URL. The next is base_URL and so on. Now the most success that I have found was using the base URL string. Almost every JavaScript file that I search this string in, I definitely see many hits. Now let's see a quick demo. here is JavaScript file. If I search for API underscore URL, you can see there are 0 matches. If I search API and URL, just API URL, we see that there is 1 match, but no direct endpoint is revealed here. If we search for HTTPS, there are 19 matches and many endpoints are shown. So this is a good starting point. If we search for /rest or rest / and similar variations, there are no matches to be found. Next, if we search for /v1, you can see there are some endpoints. For example, there is API v1 program. Then there is, I think, almost all of them are API v1 programs. But here, you can see if we search for base URL, you can see that this API v1 admin programs is generated dynamically from the base URL variable. So this is how we know that this endpoint is existent on the backend. But if we just rely on Bub.js link finder, we will not find this many times, and it helped me achieve many great bounties. So before we start with overriding, I want to tell you that JavaScript is a piece of code that is sent by the server, but it is running in your machine, your own machine. It runs in your browser. So if something is running in your machine, then you should be able to control it, correct? So JavaScript overriding is exactly that. JavaScript overriding is modifying the JavaScript that is sent by the server and modify it to suit your needs, to suit the application that you are testing. Now, why do we need to even override things? Because we are not paid to do this stuff. The developer was paid to write the JavaScript file, correct? Why do we even need to modify the JavaScript that was wrote by him? Because we need to modify the JavaScript to overcome tricky client-side encryptions, and we can also use this to find dynamically generated endpoints. Next up, we'll see a case study and a demo. So this was a report in a public program. It was my first public program bounty, so this is very close to my heart. So upon opening the page, it was a simple 404 page. Now most of me just throw the domain away by just seeing this page because it's a 404 page. There is no attack surface area, right? Many experienced people might try to brute force here, but even after brute forcing, you won't find anything because this is running currently on localhost, and I know there are no files here. But if we click multiple times on the image of the dog, we can see an alert saying dev mode enabled. So this is I actually found this thing in a production application by a multi-billion company. This might look something straight out of a CTA, but this was actually found in a production application. Now after the dev mode was enabled, many functionalities were visible to me. The first two were login and sign up, obviously. So I created an account. And I tried to log in. But when I tried to log in, the request body was encrypted. The request response was encrypted. And the whole request was signed using HMAC. This means that if I repeat the same request in repeater tab, it will not show any response. It was a single use request. Next, sir. And the nonce that you saw in the previous request was retrieved from the API v1 keys endpoint. So to sum it up, the application flow looks something like this. That once we enter the credentials, the application was sending a request to API v1 keys. It was retrieving the nonce, it was retrieving the AES secret key, it was retrieving the HMAC key, and then it was encrypting the username and password. After that, it was concatenating the nonce to the URL, and then calculating HMAC using HMAC key, and HMAC key, the URL, and the request body, and then it was sending the whole request. So that is why the request that we saw previously was totally encrypted. Next. After logging in, we see there are two more functionalities that are available to us. The first one is consultants, and the other one is my consultations. If we go to the consultants functionality, we can see there are 4 consultants. One is Barak Sensei and so on. If we click on book consultation, we can see the consultation is available in my consultations. Now upon clicking the show details button that we saw previously, a request to API v1 orders and then order ID was sent. It was a GET request, so it did not have a request body. This just makes life easier for us. Next up, we'll see how I managed to override the login function so that I can log in with arbitrary credentials and even maybe brute force them. So we can override a JavaScript file by just right clicking and clicking override content. If you are doing it for the first time, the browser will ask you to select a folder where to save the overwritten files. So we click on override content, and here is the do login function. This function is doing the actual. This function is sending the login request. So you can see there is a function called to this.process request, then API v1 login along with the request data and the post request type. Now previously the function didn't have anything, but we overrode the function and added a simple console.log. Why did we add a console.log? We just want to see that the JavaScript is actually being overridden or not. If the JavaScript is being overridden, then we'll maybe add any other code. So we try to log in, and here you can see a log in the console that says I'm overridden. That means that we have successfully overridden the JavaScript file. Now to actually get access to this process request function, we need to export this object. So we do it by clicking window.htdb equals to this. This will make sure that this object is available from our console. Now once we have exported the object, we can directly use it by typing this.process request, and we'll be able to use the process request function directly from the console. Now we can send any type of request that we like without having to worry about any signatures or any encryptions. So here for example, I am sending a login request to API v1 login along with the username and password of AAA. And it is a post request, and you can see the request is successful and the response says login true, meaning the login is successful as well. Now the orders request look like this, API v1 orders as I showed previously. Now there might be an IDO here, the IDs are numeric. So how do you even start testing this? So we'll see how to detect and exploit this IDOR manually and using JavaScript. So if we try to do this manually, you can see the first request we are sending is API v1 and the order ID is 10. That says 404 not found. We change the order ID to 8. It again says 404 not found. We change the order ID to 7. It again says 404 not found. Because these order IDs may or may not exist, but we don't know that yet. So you can see the pattern here. We have to change the order ID every time we need to send a request, but this is not feasible. If we want to enumerate order IDs from, let's say, 1 from 1,000, we can't go on and type and call this function every time. That will take way too long. So to overcome that problem, we can simply use a for loop inside the console. The for loop, the example for loop here starts from 1 and it goes to 10. So we are just checking if there are any orders from 1 to 10. And right off the bat, we see that the order ID 1 is found. The order ID 1 is by user ID, also 1. But if we check in the above screenshot, our user ID is 4. Meaning we are able to retrieve orders from another user. And all of this was automated by this for loop. So to summarize, we found a page, we found the hidden error mode, we logged in, we signed up an account, then we logged in, then we found the orders functionality, and we exploited it using JavaScript to retrieve orders of other users. Now here is some bonus content. This actually doesn't belong to web application, but this belongs to mobile application, Android and iOS application. But this also contains JavaScript, and this talk is about everything JavaScript. So that's why it is here. So what is a bundle? First of all, a JavaScript bundle is a combination of all the client-side code along with all the libraries, so that the application can run without having to access the external libraries using internet. If it is an Android application, the file will be index.android.bundle. If the application is an iOS application, the file will be main.js bundle. How do you know that a file that is index.android.bundle is an actual JS bundle or not? So you can simply run the file command on the bundle, and it will say Hermes JavaScript bytecode. So that's how you know that it's a legit bundle. You can also simply try to cat the file, and it will throw random gibberish. Again, we are not robots. We don't know all of that, what all of this means. Next. To convert all of that gibberish into something that we can actually analyze and something that we can make sense of, we can use the Hermes -DEC tool. This actually Hermes DEC tool contains lots and lots of many tools that we can use to analyze this. Next go. One of them is HBC-decompiler. So this is part of the Hermes-DEC toolset. How do you unbundle a bundle? You simply write HBC-decompiler, then the bundle name, and the file to which we want to store the output. After the tool is done running, you can see the output shows something like this. This is not actual JavaScript. This is just this is basically something that you can make sense of. Next up, we have a case study in this bundle thing. So this was in a target on Synac Red Team, where I found AWS secret keys inside a JavaScript bundle. So first, I just simply decompile the file using APK tool D, then the file name. Next. Then in the assets directory, I found the index.android.bundle file. You can see we ran the file command, and it shows that it is a Hermes JavaScript bytecode. I ran the file through HBC decompiler tool. It showed the output in the unbundled.js file. And in this unbundled.js file, I searched for strings like base URL, base underscore URL, API URL, API underscore URL, and so on. So first we searched for base URL, and it showed many URLs. Next up, I tried searching for secret. Now, when I search for secret, you can see there are various strings that match secret, and one of them was AWS secret keys. Obviously, I'm not going to show the screenshot here. and while trying to take screenshots for this particular presentation, I came across more secrets inside this file that I didn't initially found. So that was it about the technical side of stuff. Next up, Satyam will take you through mindset stuff and more about how he finds many crazy bugs just through mindset. So over to you, Satyam.
So thank you, Kuldeep, for all the technical insights. Now, for the people who are sleeping or who might be as lazy as me, let's see what is in store for you guys as well. We were supposed to remove this. Okay, so almost every one of you might have, especially in India, you might have that one annoying neighbor who keeps on asking you questions and who want to know each and every detail about your life, right? So this is the mindset that we need to have when trying to analyze JavaScript files or manually looking into the client-side code. Keep asking what if, assume that the developers are lazy like me, and stop taking things at face value like that annoying neighbor, and try to find every intrinsic details about the code or the analysis that you are doing on that file. So for example, and to back this, this is just a snippet of JavaScript code that I came across in an application which I was testing on. And after 2 to 3 days of tinkering around, this is something which I came across. And this might not seem trivial, but if you look closely, there is a space in between the bearer and the token when it is getting appended. Now I'm not sure if this was the exact reason of the bug that I found, but this seemed interesting to me, and I tried a bunch of things. But finally, if you can see, by providing just a single space after bearer and passing that as an authorization token, I was able to bypass the authentication of the web application. So anything, if you try to provide anything apart from a single space, you are thrown a 403 or 401 forbidden code, and you are not able to access that particular resource. And this was just around 1 or 2 months back, I guess. So welcome to 2024. This was a subdomain of the same target, and for this, the same thing did not work. A single space was not working. So instead of that, I again tried a bunch of different things. But as you can see, any alphanumeric character, just a single alphanumeric character, if you append after a bearer, we were able to bypass the authentication and access all these endpoints. So this was again, welcome to 2024. Now, how many of you have been in a situation when you know and you are certain that there is absolutely nothing in the fridge, but you still keep opening it and in the hopes of finding something new? How many of you guys have been there? So, great. Now that is again another mindset that I want you guys to have when trying to perform bug bounties or pen testing or whatever it is, right? So always assume that I'm stupid. So that means, like, for the first 2 or 3 times you are trying to analyze that file or that application, you are not going to find anything. Stubborn me. Unless and until you do not find anything in that application, don't move on. Even if it's a very small trivial thing, as we saw in the previous example, if I had just given up, like nothing is working, then I wouldn't have found that critical bug. And assume that everyone is noob. The bug that Kuldeep showed was found in a public program, and it is a very mature bug bounty program. So a lot of hackers already might have looked at the, at the target probably. But assuming that it would have been found or something like that, then we would not able to have found that issue as well. Now for another example, here is just a GraphQL query which I had found in a target. This was probably for Synac, if I remember correctly. And this is just a query which creates a referral code, right? So the issue here was, this is a target that we usually keep on hunting and coming back to, right? So 2 to 3 months back, there was a similar query which was present in the application that we found through the JavaScript code, that which was referral details. And it was exactly the same endpoint and exactly the same query and returned exactly the same things that referral detail returned. But referral detail was not present 2 to 3 months back. And it was not present on the target when we were testing initially. But after we already had reported referral details and we had already awarded bounty for that. Now 2 to 3 months back, again we found referral detail and we again reported that. And we were so certain that it would not be accepted in the first try that we also added a comment with the screenshot saying that this is not a regression and it's a completely different query, so that the triager do not get confused. But as expected, they initially rejected our vulnerability, saying that it's a duplicate which contained the exact same query and method. But finally, they had to agree that it looks like we missed the S. So this was just to show you that how trivial or easy things can be, and we do not need to make everything so complicated. Now let's just see some other examples and case studies to back the mindset part. Now this was another piece of JavaScript code for another application that I was testing on. And I tried a bunch of different things. If you can see, there is a path or query, there is an API path which is being formed. Now here I tried a bunch of different things and I replaced the ID and X with numeric stuff and tried a bunch of different things, but nothing was working. It just kept throwing a 404. But what interesting part I noted was, after the test API, if you see, there is no slash. So I got curious and I just tried this and it worked. So basically, I don't know if the developer did it by mistake or this was intentional, but instead of test API/API, if we provided test API without any slash, that led us to bypass the authentication and access for the endpoints. So this was again very simple, and this was just a piece of code that we found in the JavaScript file. Let's see another example. Now for the IDOR part, which Kuldeep shared with us, he probably shared the target with me and he explained to me the scenario of unbundling and minifying and everything 2 to 3 days after 2 to 3 days after that. And I was just exploring the target which we were discussing on, and I was just the objects, the request as we saw were all encrypted, and I was just exploring the console part and opening all the objects one by one. And in that we found, I don't think if it's visible or not, but as you can see, there are current addresses which are being disclosed directly to any end user. Along with that, there were also PAN cards and Aadhaar card numbers being leaked as well. And for this, I hadn't even opened Burpsuit itself. So this was just basically F12 hacking that all the Twitter bros keep telling about. So that was it. And that was all for the talk. And for the key takeaways, as you saw, like, nothing is obvious. Ask stupid questions, try stupid things. Nothing is obvious. You don't know how the developer is thinking, what is their mindset, and how are they going about things. Find your thing. It can be recon, it can be automation, it can be manual hunting as we saw. But find your thing and try to be as good as possible in that. Keep things simple. Explore, don't abandon. So if you are good at JavaScript or let's say recon, always try to explore different things, or let's say AI is getting crazy nowadays. So explore those things, try to learn new things, but do not abandon the basics and keep forgetting that nothing is obvious. Stay hungry, stay humble, and don't collaborate. Don't just collaborate, make friends, so that when you find such lazy bugs, there can be friends like Kuldeep who can explain you all the technical jargons and all that kind of things. So that was it from our side. Thank you so much. And if you have any questions, feel free to ask.
Yeah, hey guys, it was really a nice talk. So I'm Loveless Joshi. And actually, it was nice demonstration, nice PPT and all.
Thank you.
Yeah. So I have a really basic question. So when you explained around the React.js applications, so these days only a specific bundle is loaded in the front end, not the entire application, right? So how do you guys what is your approach to test that particular application? Because a specific bundle is loading and there might be hundreds of bundles, right? So how do you guys automate that thing? Do you download each and every bundle? How do you inspect those things?
I think Kuldeep will be able to answer that better.
Yes.
Oh, actually, I don't automate anything. If there are like 50 bundles, I will download all 50 of them and analyze all of them manually. So that's just me.
Okay, so there is no automated process.
No, sure, there are a lot of tools available, right? Everything you saw there is probably a tool which might be able to do it better. But as you saw that AI or the tools, they lack context and clarity. Like they do not follow intuition. They follow regexes. They have a specific set of rules that they follow and repeat over. If for example, let's say when I showed that bug where we just included a single space, if I had automated that through a tool, it might have missed a tool, or scanner might have missed that, because that's just our human intuition that we tend to dive into rabbit holes. We tend to go with our intuition. That doesn't happen with automation. So I'm sure there might be some tools which we are not currently aware of to automate that kind of thing, but this is just our approach and we like to keep things simple.
Cool. That was nice. I have one more question. In the start of your talk, you mentioned that uploading a JavaScript file to a AI tool, basically any ChatGPT or so, is not recommended. And you said around the size, like around 8 MB or so, I guess. So, I mean, have you guys tried to upload a zip in AI and all? Like you could just zip a application and a code.
No, actually, I tried to upload it. I do try to upload it to an AI, but obviously it said that the file is too large. I cannot analyze it.
Oh my god. I guess you should try some new models. But yeah, guys, it is available. In these days, we can upload a zip. And it does the good job, actually.
Okay, I will definitely try it.
Yes, thanks. Oh, yes, thanks. It was a really nice talk.
Along with that, usually we don't want to analyze each and every aspect of the JavaScript. There might be billions of things in JavaScript. We just have a more concentrated approach, that if we are finding some custom function, if you are finding some critical logic that you might think might not be on the client side, then you can focus on that parts, and you can definitely throw those parts into AI, and then you can analyze that as well. So it works that way as well.
Hello. Thank you for the presentation. It was very nice. So my query regarding the one with the Kuldeep show, it was the overriding part. So could you move the slide to that part, overriding? I have a couple of questions on that part.
Yeah, sure thing. Just tell me when you want me to stop.
To the one where you edited the code and you mentioned the overriding part. Yeah, this one.
Here.
Yeah. So here you modified the JS file.
Correct.
So it is a server side where you modified, or it is like after overriding you?
It is. I modified it on the client side only because if you can modify on the server side, it will be basically remote code execution.
Correct. So basically you edited. I never came across this scenario. So basically you save the file, you edit it, and after that you so while the server is taking the client side input, not the server side. So basically you modified this part, right? And after you enter the input, right?
Correct.
So after that in the console you got this I am overridden, right?
Correct.
So basically it is the client side where you have modified and it got
correct.
reflected.
So basically we are telling the browser that do not use this the JavaScript file that is provided by the server. Use the JavaScript that I will provide. I am the one who knocks.
That's good. And there are a couple of questions as well. So have you come across the JS Finder? The couple of scripts are available basically in order to find the sensitive details in a JavaScript file. JS Finder, a couple of scripts are available. So you might have come across such script, automated script?
Now,
Is it
are you
JS
asking
finder?
like for BubJS link finder or any other scripts?
It is random finder basically in order to find the sensitive details in a JavaScript file. So is it a worth? Just wanted to ask.
Oh, there are many tools available, but we mostly follow the manual approach.
Yeah,
I
that's
mostly follow the manual approach.
That's good. That's good. Yeah. Thanks, Viraj here. So thanks, Kuldeep and team.
Thank you.
Yeah.
I have a same doubt. Doubt in the same page.
Okay.
It might be a dumb one. I'm sorry, but this is a local. You have made a local copy of the JS file and
Correct.
you have loaded it from the local storage, right?
Yes, correct.
I have done a similar thing with the Chrome Dino game, right? I have automated the Dino to jump on its own, detect the obstacles and all. I do understand that, but the thing is, it is a local copy, so this version of the copy exists only in your laptop
Correct.
or PC or anything. So what's the impact of this bug?
What's the?
Impact, like what happens?
So we are overriding it on the local file system, but why are we doing it? We are doing this so that we don't need to see the JavaScript file here knows how to encrypt and sign the requests. We have the AES keys, we have the HMAC, we have the nonce. We can do it ourselves. We can send the whole request by ourselves, but you can do it for maybe one request, maybe two requests, maybe 10 requests. But if you want to do it repeatedly, you might want to use some sort of help. So this is the help that we are talking about. We are overriding the local JavaScript file so that we can send HTTP request just directly from the console, so that we don't have to do it manually.
So if you want to do manually, you can just go to the console and call the function directly.
Yes, correct. That's what we did here.
To make that process happen every time you want to do it, you edited the file, that's it.
Correct. That's all.
Okay, got it.
So this is not the vulnerability. This is just what do you say?
A way
A handy
of
tool.
approaching the problem.
Yes, correct.
Okay, I got it.
I think that's it. So we'll conclude. Thank you so much.